Today, we're going to look at how long it takes a ball to stop bouncing. How we are going to do this is very similar to calculating the distance the ball travels. The way we are going to do this is we are going to calculate the time it takes the ball to complete each bounce and sum all those times together to get the total time that the ball bounces. Then we will have calculated how long the ball bounces. The process we will take is first we will calculate the time of each bounce, and then we will sum all those times together. Some assumptions that we'll need are 1. That the initial height of the ball is h naught. 2. Each bounce of the ball is proportional to the previous bounce by a factor of p. And 3. Acceleration is constant. For example, if we are on Earth, we would have gravity. What we'll need to solve this problem. 1, we'll need some kinematics. We'll use the equation S of t equals negative 1/2 at squared plus vt plus h. 2, we'll need the energy of a system, which is kinetic energy plus potential energy, which is 1/2 mv squared plus m times a times h. And 3, we'll need our formula for our geometric series, which is 1 plus x squared plus x cubed plus equals 1 over 1 minus x, where the absolute value of x is less than 1. What we are going to do now is we need to calculate the time it takes the ball to complete its ith bounce. There are 2 ways we can do this. 1, we could use an energy argument, or 2, we can use a symmetry of parabolas argument. I'm going to use an energy argument. We know the total energy of each bounce is kinetic energy plus potential energy. By my previous video about how far the ball travels while it is bouncing, we know the max height of each bounce is hi. That means the max potential energy of each bounce is m times a times hi. We can use this to calculate the initial velocity of our ball for each bounce by setting 1/2 m v naught squared equal to m times a times hi. Because our height is 0, the energy of our system is all kinetic. Solving this, we get v naught squared equals 2a times hi. Thus, we get v naught is equal to square root of 2 times a times hi. We take the positive root since our ball is initially going up. We can use this velocity to calculate the time the ball bounces by setting our kinematics equation S of t equal to 0. In this case, S of t will equal negative 1/2 at squared plus the square root of 2a times hi. We can factor out a t, and then solving this, we get t is either 0 or t is equal to 2 times the square root of 2hi over a. We know that hi is equal to p to the I times h naught, so ti equals 2 times the square root of 2h naught over a times pi. Now we are going to calculate our t total, which is t naught plus t1 plus t2 plus . We know that ti is equal to 2 times the square root of 2 times h naught times pi all over a. T naught, the ball just drops down to the ground, so we only need half the time for our initial bounce. Thus, we get our sum, which is square root of 2h naught over a plus 2 times the square root of 2h naught over a times p plus 2 times the square root of 2h naught over a times p squared plus . We notice that 2 times the square root of 2h naught over a is constant in all the terms, so we can factor that out, and we are left with a 2 times the square root of 2h naught over a times, then in parentheses, square root of p plus square root of p squared plus square root of p cubed plus so on. We can move these powers to the outside of the square root by our rules of exponents, so we'll be left with square root of p plus square root of p squared plus square root of p cubed. We can then factor out a square root of p, so we happen to have a 2 times the square root of 2h naught over a times square root of p times, in parentheses, 1 plus square root of p plus square root of p squared plus dot dot dot. This happens to be our geometric series, 1 plus x squared plus dot dot dot, where x is equal to the square root of p. We can substitute this in 1 over 1 minus root p for the series. Now we're left with square root of 2 times h naught over a plus 2 times the square root of 2h naught over a times square root of p times 1 divided by 1 minus root p. We can factor out a 2h naught over a, and we are left with square root of 2h naught over a times 1 plus 2 root p over 1 minus root p, and simplifying this down, we get square root of 2h naught over a times 1 plus root p divided by 1 minus root p. Thus, the total time that the ball is bouncing is square root of 2h naught over a times 1 plus root p divided by 1 minus root p. A quick example to close things out. Imagine that our initial height is 5 meters and our p is 0.7, meaning that the height of each bounce is 70% of the height of the previous bounce, and our acceleration is gravity, which is 9.81 meters per second squared. Plugging everything in, we get 11.35. That means that the total time the ball bounces is 11.35 seconds. That's everything for today, and thanks for watching.